بسم الله الرحمن الرحيم. نرحب فيكم في سيشن 2-3 اللي هو الانفستمنت سستينابيلتي اند جفرننس. معكم دكتور يوسف الوزان. لاست مينت يعني دعوني اني ادير الجلسه، وانا صراحه اتشرف اني التقي معاكم واستمع الأوراق العلمية لكم. فعندنا محاضرات أونلاين، في عندنا محاضرات شخصية موجودين. فراح نبتدي اليوم مع أستاذنا العزيز عيسى قمبر. Professor Isa Qambar is a fellow life member of the Bahrain Society of Engineers and serves on Bahrain's Council for Regulating the Practice of Engineering Professions, CRPEP, at the University of Bahrain, where he was a professor. His leadership included roles as Dean of Scientific Research and Dean of the College of Applied Studies. He's also the founder and honorary chair of the IEEE Bahrain sections. Professor, glad to be with you today, and we will enjoy listening to your lecture regarding the global innovations and technologies in solar energy infrastructure projects. And we hope that the solar will be integrated with everything, including the desalination technologies and...
We'll talk, inshallah. Bismillah ar-Rahman. Thank you very much, Dr. Yusuf al-Wazan, for your presentation. And just I'll go through, our presentation here about the solar energy in Bahrain. So I will talk about Bahrain, and I will give some more information about Bahrain here in our presentation. We know that everywhere they are using the panels, the solar panels everywhere, to be included and to generate power. Even in Bahrain, when they are going to use it, we have to think about a very important point, especially about the land, because we have a very small land in Bahrain. So in this case, if we use always the panels, it means it might cover most of the land in Bahrain. So here, I will talk about some of the power stations which has been already started in Bahrain, and how we can try to eliminate that part about the solar panels and include another part which will save land there. So these are the places we have there in Bahrain. We have started with University of Bahrain, and at the same time Awali power plant for this one, and it was generating just 3 megawatts, which is very little, if we want to talk about. At the same time, the government start to think another plant where they can install the panels there. So the second one, it is Askar Solar Farm, and Askar, it will generate 100 megawatts. So 3 megawatts, and it has been jumped to 100 megawatts. It means we are going to get better power there. Then after that, they think about Sakhir. Sakhir there also, they have a plan for the future to install, and they have already started, or they are expecting to start by 2027. For Sakhir. And after that, and the next part, which is the تطوير power plant, where it is a petrol company there in Bahrain, and it will generate 3 megawatts. Then about the Dur solar power station, which has been already started with. We have a gas power plant there, and they include the solar one in the Dur, and it will generate between 90 and 100 megawatts. And the latest one, which just signed the MOU between AWA, Electricity and Water Authority in Bahrain, and University of Bahrain, and they start to think about, generating 46.2 megawatts as a photovoltaic in the photovoltaic field. Now, what will be the challenges they are facing? As I said, one of the major challenges you are facing in Bahrain is the limited land area, because it is a small country. The second one is about the financial and technological constraints. And the third challenge is the solar and wind into the national grid process. And the last one is Bahrain. It needs to establish comprehensive regulatory and policy as a framework for these. And they have already, if we think about this part, especially about the last part, also the government plus the GCC, they start to put some regulations where they can continue with to establish the solar power plants. Now, these are the future aspects which we are thinking about for renewable energy in Bahrain. One is the government commitment and vision of 2030. So they have it there in Bahrain, and they are expecting by 2035 they will establish at least 10%. Then the next point, investment in research and development, where they are thinking about research and development as a crucial for renewable energy. After that, the third part, or the third point, regional collaboration, where we have to collaborate with the GCC countries as well. So we cannot work alone. And we have to put, especially about the weather, and if we want to think about so many things about even the temperature, especially about the temperature in Bahrain, it will be almost similar in all countries of the GCC. And the fourth point is sustainable urban development. Though here the development, always we have to think about the smart cities, where we want to save energies as well. The fifth part is the solar sphere, and this is what I want to talk about here in my presentation, because we know the solar sphere, it will save the problem of the limited area in Bahrain. So we can install the solar spheres vertically. So in this case, we are saving energy. At the same time, if we think about the solar, it will generate about 32 times what the solar panels generating in the power. And the number 6 about the projects which has been already used, it has also advantages and disadvantages for sure, but about the maintenance for the spheres, it will be better than the solar panels. And it will be easier, and it will save even time and land, plus it will save money for the countries. Here are some results which has been done for the spheres, because we know that the sphere, when we have it, it will have a media inside. So it will have like some oils, or even sometimes might have water, or different types of oils. So it depends here on the volume of that amount of oil. So here, what I start to do, or what I've already try to plot till the value 8.4 as a volume in liter. It has been done already as an experiment, and we have recorded the values for the volume and how much power will be the output power there. And after that, I developed the model for this curve, and I start to find out what I am expecting if we go till like 19.4 liter. How much power will be generated for the sunflower oil here. It has been concentrated on the sunflower oil. After that, I try to find what will happen if we change the density itself for the oil. If it has been changed, it means the red colors, it means the recorded values or the experiments done. And the blue colors points, it is the expected for the future. And at the bottom, we can find the power output in watts. And how can we get that power output if we change the density, which is going to be in kilogram per meter cube. The next one, if we try to change the diameter of the sphere, because we know that each sphere will get a diameter. So the diameter, if we try to increase it, it means I am going to increase the output power as well. So here, we start also the red values, which has been recorded according to the experiments done. But the blue one, the expected, and based on the power output at the bottom of the page, we can find the model. This model I try to also to develop by myself. All the three models has been developed by myself to find out the future values. Then the next one, here it will compare, as we said here, when I wrote the first point, which is PV, it means the photovoltaic, which is the panels used. And if we want to find out or compare it with the diameter here for the spheres, we can find that the difference is much. So here, the PV, it means it will be, very little or small amount of power. And here, for the sphere, when it's going to be air, it will be a bit better. But if we change it to water, it will become better than even air. And after that, alcohol, and the last one will be the oil. And here, the values, we are going to get it for the spheres, about the diameter of that spheres, and how much we are going to get. So if we compare these values, it means the best is to shift to the sphere, the solar sphere. Now, in this case, Bahrain, it is progressing for the future, even for the solar. And if we want to find out for the injected power, it is expected to get around 250 megawatts as a power or solar power for the future. And the government also, it is plans here to be by end of 2026 to get that amount of power. The same thing here for the major developments. As I said, Sakhir solar plant will make 28% of the government target, and Bahrain's first solar project, which has been already done, 5 megawatts. Tatweer, which is also mentioned at the beginning, it will be like 3 megawatts. Askar solar farm, it will be 100 megawatts. Ad-Dur, which is between 90 and 100 megawatts. And UOB, it will be 46.2 megawatts as a photovoltaic. Then, to conclude, also for the future, the renewable energy sector here in Bahrain, it looks to be better and bright, and the use of new technologies like the solar spheres, it will be more better and it will give more power even, and more efficient power as well. And the cooperation between Bahrain and GCC, it will be better and better. So reaching to the objective, for the predicted future power output, it will be based on, as I said, the viscosity, the the diameter, and at the same time for the type of the media inside. So thank you very much. And if anybody has any question, you are more than welcome, or any comments even. Thank you.
Thank you, Professor عيسى, for the excellent presentation, very informative. If anyone have a question?
Thank you very much, Matthew, for this question. The experiment has been done in Abu Dhabi, in Al-Ain University. It has not been done in Bahrain. So I got all the historical data from, but we hope, because here I talked to Bahrain University and I talked to some of the officers there, if there is a possibility to start doing this experiment in Bahrain and to start to change even the type of oil. No, because it is a real sphere, really. And we have to, it is from a glass. The sphere it has become as a glass. And even there's a point which I did not include it here, even the take in consideration about the thickness of the glass. If we change the thickness, it will affect on the values we are going. It is not only for the diameter, but even for the thickness of the glass.
Obviously, you use the manufacturer especially.
Exactly. Yeah.
Thank you. If I can, if you can introduce yourself. Yeah, hello, Fik. See, our renewable energy is a different world. We are dealing in the desalination sector.
Yes, and Engineer Mahdi did mention about a very important point which I missed to talk about really, because you see the solar panels, sometimes you have to adjust it based on the direction of the sun. But here for the sphere itself, there is no need to change the direction. It is going to be fixed, and even for maintenance, it will be so easy to clean it and do the maintenance for it easily, better.
Yeah. Anyone has any question? I have. It's very interesting, Professor. I'm sorry for my ignorance, and it's not my field. Okay, I'm very interested to utilize this and integrate it into the different desalination technologies. Whether it's the reverse osmosis technology, or it's the forward osmosis technologies, or other future desalination technologies. My ignorance, and then when you showed your blot, okay, you are talking about air, and then you ended up with oil, alcohol, or
and oil,
and oil, air, water. So you involved water. So my question is, what do you mean by the different liquids that you are, different air.
Yes.
What I know is the solar panel, sun will come, and you generate power out of it.
Yeah.
But if you can teach me how.
Yeah. For the first point, it was really when I want to talk about the photovoltaic as a panel itself. The first point, but the other points, I will get the diameter for the sphere, because as I said, the first point is only about the solar panel, which is going to be like a sheet. But the rest, it will be the sphere itself with different diameters. So when I increase the diameter for different type of media inside the sphere, the glass sphere.
Oh, then you're talking about the media inside the sphere, whether it will be air or water or alcohol or oil.
Exactly. This is what I want to
How
do.
would that media to transmit the light? It's the same principle of the fiber of the
Yes. Yes.
Exactly.
I just wanted to clarify this because for me it's
Sure, yeah.
it's unclear. It's very interesting because, I mean, utilizing desalination and with the integrated with the renewable energy, we have integrated two desalination systems.
Yeah.
It's one is the forward osmosis and the other one is the reverse osmosis technology. In the forward osmosis technology, how the water transfers or the potable water transfers through the membranes. If you have saline water and then you have drinking water, then naturally from low density to higher density, the fluid will flow. That's why, I mean, in reverse osmosis, the water will transfer from low to high, then it reaches a certain level, and then it will stop. Okay, the difference between the levels is the osmotic pressure. We have to apply higher pressure than the osmotic pressure to reverse the situation. And the forward osmosis technology, it's natural. We have a solution which is higher than the seawater. Okay, so it transfers naturally. But the thing is, we need energy to separate heat, to separate the solution from the drinking water. So here we need, a solution. Yes, to separate the drinking water. So that's why we do need, to do more studies than, especially for our areas. Professor, he's talking about the area. Okay, so his idea is really it's very interesting, and maybe we can collaborate in future work. I used to be at Kuwait Institute for Scientific Research at the Water Center. We've done a lot of, we dealt with so many different technologies, but at the end, it's energy. It comes as an obstacle. So maybe we'll contact,
Well, more than welcome. And even, you see, when I talk about viscosity, because just to talk about it in Arabic, نعرف لزوجة المادة كل ما تكون لزجة أكثر كل ما يكون أفضل حق عملية المحافظة على الابزوربشن اللي هو الامتصاص للكهرباء أشعة الشمس، وخاصة عندنا ما شاء الله أشعة الشمس 24 ساعة يعني، فبتكون يعني موجودة فبيكون.
But it's collaborating between the GCC countries, especially we are working in similar areas. I mean,
exactly.
We're all connected, same whether if we can work all together.
Inshallah.
So we can reach, because you can't do the experiment in Bahrain.
Sure.
Where the humidity is higher than
in Kuwait. Yeah.
And we can maybe compare the efficiency of your system. This is one.
Exactly, yes. Thank you.
Appreciate it, Professor.
Okay, you're welcome.
I enjoyed really
Thank you very
listening
much.
to your presentation. Now we move to the second one, if we can put the how to get this. Yeah.
خلنا نوصل كده عشان ندخل على
Okay, if you can help me, Professor.
إن شاء الله.
See, the retirement makes.
لا ولا يهمك. هاي البرزنتيشن.
I'm enjoying retirement, but not really.
Okay. So here the
Okay, now
Number
I
one,
need
which
number 22, number 22, number 22. Here. Okay, then it comes to. This is the one? Yeah, Ashkenani. Okay. Our next presentation is the role of artificial intelligence in enhancing sustainability and investment efficiency in smart energy infrastructure projects. Our speaker will be Abdullah Abdul Wahid. بالانجليزي على بعض ارد اسوي التونينج. Okay, is the CTO of Enviro Group company and a member of the UN Habitat Gulf Region Office scientific team. He holds a master degree in mechatronics. This is something new. And robotics. Okay, and bachelor degree in electrical engineering with a strong technical and strategic expertise in robotics, AI systems, and sustainable innovation. I'm really glad that you are here, and I'll be listening to your and everyone else. I will enjoy it. Anything with robotics.
Inshallah, you'll enjoy it. Thank you for the nice introduction. So we'll start. First with our problem that we're facing in the Gulf region. First, we have a rapid demand and growth in the Gulf region related to the power grid. And we have high cooling and peak load stress, renewable unpredictability, and increased investment risks. So, we looked into this field and we found a few gaps. The first gap is the conventional forecasting lacks adaptability. It's pretty rigid. And then we have rule-based control is insufficient. So most systems rely on, let's say, if-then system. If this happens, this happens. But it's a bit inflexible and it causes lots of costs, let's say, increasing and lowering efficiency. And lastly, we have sustainability not linked to investment efficiency. And this, for me, this is the biggest challenge we're facing right now. So what does Enviro Group proposes? We propose an AI architecture integrated to our grid systems. This system consists of 5 steps. The first step is data acquisition. Basically, we use sensors to gather data about the weather and about the loads we're having. Then we send these data to our edge processor, which is like a computer that processes all the data, then pushes it to something we call LSTM neural network, which is long short-term memory neural network for load forecasting and predictions. After we have our predictions about the weather and the loads and how much energy we're getting from the renewable energy plants, we give these predictions to something we call a reinforcement learning agent. Reinforcement agent, learning agent, is basically the algorithm that decides what to do to optimize efficiency in our system. After that, we integrated to simulation in MATLAB and Simulink, MATLAB/Simulink, and we simulate the whole smart grid system. Okay, so let's dive deeper into this idea. On the left, we have our physical layer. We have the sensors and the edge processor. For example, something like NVIDIA Jetson. We get the data that we need. Then we link it to our AI algorithm. The AI algorithm, as you see on the top, consists of two parts. Then you look at the bottom. Sorry, it's a bit complicated. We look at the bottom. We have first our LSTM neural network. We feed it data. We make it learn. It discovers patterns and kind of rules. Then it sends these patterns and rules to our reinforcement learning. Oh, sorry, my mistake. Okay. We send these predictions and forecasting to our reinforcement learning agent. Reinforcement learning agent works as a child, funny enough. We teach it through rewards and punishments. So through the simulation phase, we reward it for every action that optimizes efficiency, and we punish it for every wrong decision it makes. So by that, it will have like an idea of how to take the right path into our goal. And lastly, we integrate the whole thing in MATLAB and Simulink, and the whole process goes back again. So it's a closed, continuous, intelligent loop that senses, predicts, optimizes, implements, then repeats. Now, what was our MATLAB framework? Our MATLAB framework had three criteria. First, it had to have city scale and facility level models for accuracy. Then, for the small details that we're actually struggling with is hourly demands and climate data that determine our peak loads and sometimes cutouts. And lastly, we'll have simulation-based evaluation. Now, let's look at the results. We first focus on the forecasting results. As you can see, we have actual load in blue, orange for conventional forecasting, and green for LSTM forecasting. We discovered, you can't see the blue because our LSTM is so accurate. We discovered that the LSTM is 20 to 25% more accurate in predicting actual load, which is extremely efficient, or extremely beneficial. We move on to the operational cost reduction, and we compare the conventional costs and the AI optimized costs, and we have from 15 to 20% cost reduction. And this will help with the sustainability meeting investment goals. And lastly, we have carbon emission reduction. Again, conventional emissions versus AI optimized emissions. And we have from 10 to 12% CO2 emission reduction. Now, to the investment impact. If we implement this system, inshallah, we'll see reduced operational uncertainty because of our LSTM accuracy in predicting the future or the future loads. Import project bankability due to the low cost and long-term financial sustainability. To conclude, we saw that we have 25% more accurate predictions. We saw that it would cost 18% less to operate and 11% reduction in CO2 emissions. So if we're using technology and AI for everything, why don't we use it for the greater good of this planet? And thank you.
Thank you very much for very informative information. Very informative lecture. AI at the end is the future. Now we see, I mean, even wars, everything is depends on AI technology. Even the university students and the students, they all using the artificial intelligence to help. So we don't know, I mean, in the near future, whether we're going to have universities or, according to Dr. Mirza a while ago, he's an economist, said with regard to AI, we don't know whether we're going to have universities or the universities will be only historical or it's history, or will be museums, as according to what he said. So AI is very important. Our telephones, our mobiles, I know that AI needs a lot of cooling. Okay, that's what they are talking about. That it's with regard to the CO2 or the carbon problem that they have. So my saying is, anything that human-made has advantages and disadvantages. So I really enjoyed it. I would like to leave the floor for our audience if they have any question.
Yusuf from Bahrain. I think it's okay. It's okay. It's okay. Is your proposed solution, is it linked to any AI brains?
We haven't really decided yet. We're trying different agents, different, let's say, companies, but they're mainly performing the same. Yeah.
So you're going to build your own intelligence really this way?
Most likely, yeah. We're gonna build like the reinforcement learning agents.
Because reward and punishment, that means you need to do a lot of learning to build the action. That will take you longer. It's going to be more complex than utilizing existing brains.
That's true.
In my opinion.
Yeah, that's true. But we're also thinking about cybersecurity and safety. That's also why we kind of host it locally to the edge. So it has faster response and safer in data.
Okay, forgive me, just one more question.
Yes, please. We are enjoying this.
Sorry.
No.
It's not
good.
clear for me. You are a private company, Enviro Group.
Yes.
So how are you monetizing this? So you are Kuwait, yeah? Not Saudi. I was going to say SEC. What is it in Kuwait? Karaba? MEW? Yeah. Okay. So MEW is your client?
We're still in the initial phases. Yeah. We're still in the
So it will be, you're hoping for MEW to be your client? So
great.
how are you going to monetize your investment? Because it wasn't clear for me.
It's not really about monetizing, it's just lowering the cost of the infrastructure itself. So it's not really directly bringing money, it's just saving costs.
You're spending money.
True, yeah, it's true. True, but that's why I was saying, like today's, let's say, renewable energy has a lot of investment process, especially for the private sector. Right?
Yeah.
It has regulation change and all that. So with our system, inshallah, it will be, let's say, more flexible to do.
At the end of the day, you have to make money, so I hope you will make money.
Inshallah. Exactly. So we have. Is it a part of maintenance? No, it's not part of maintenance. So when you teach an AI, you have three methods. You have supervised learning, where you feed it like your private user. You feed it information. This is right. This is wrong. Then it will have something to go back to, like a rubric, kind of.
Is there a way to prompt something like a command?
It's kind of yes. And we have unsupervised learning where you just throw it in the deep end and you learn by yourself. Or we give it the reward of punishment. Imagine you have like 5 years, right? If this 5 year does something like you punch, right? So it doesn't do it. If it does something good, you reward it. And the reward will force it to optimize its output.
Thank you very much, Abdullah, for your presentation. Really here, when we want to talk even about AI, it means that even I'm going to use some tools, and it depends on the historical data. Now, when you start to expect, for the future, the load dispatch or load expectation, so it means you are going to use a tool like the neural network or the fuzzy logic itself, because it is a type of AI. So in this case, did you use the neural network as a tool in your project?
Yes, we did. And that's how we got the accuracy numbers. We compared it to the confidential forecasting, always.
Especially even you can include a part of it, like how accurate it is going to be, and just for the future, I would suggest something like to find the models for it, where you can exactly find out what will be the future results is coming for the future. Thank you.
Thank you very much. في سؤال؟ في واحد ينظرنا اونلاين. شكرا. ما قصرت، انا كان عندي سؤال متى راح بالروبوتكس والامور هذه نتخلص من هالوايرات؟ خلاص فور جود يعني واير ويتنج يعني، لان our work we need the data that will be transferred using the AI from especially in the far away places in the desert, like for our aquifers, for our weather, or what. So we do need these intelligence to help us in our research work and in our future actual work.
I actually presented a study also about this, like how we get the data too far, like let's say plants or.
Yes, thank you very much. احنا في عندنا 48 أنا is waiting online. So 48. I don't see his. ظاهر مو موجودة. منكم بس. هذا هو راح يعرضها من عنده.
اليوم
48 مو موجودة هني، بس ما أدري هل هي 48 تبع يقول ينطرنا ناطرنا. ما أنا حاولت 48 ولا هو راح يحطها. 47 موجودة، 49 موجودة.
الجدول بالطبع لك يا دكتور؟
لا كان هو 48 رجيف.
إيه موجود؟
هو المفروض إذا طلعوا لي إياه بزوم. طلعوا لي إياه بزوم، هو ناطرنا كأنه دز مسج إنه we are waiting for. هل هو راح يحط البرزنتيشن تبعته؟
إيه كان موجود.
أوكي على أساس أعمل لنا لينك معه.
لا تحط.
تقاعد ما يسوي.
ما له علاقه والله التقاعد.
كل سنه الملتقى توك شباب.
انا الحين قاعده اواكب عيالي صغار كل ما انا ينزلون شيء يجي تعالي شوف صورتي مع مين اطالع. ايش قاعد تسوي؟ والله مستخدم الذكاء الصناعي حاط صورته مع ممثل حط صورته مع مالك والله ما يبين شو المسج. فالحين لازم نواكب الصغار هم يعلموني. اكلم مع الواتساب واحد يقول لا انا منزل انا ما استخدم الواتساب. يعني وش تستخدم؟ تعال على وش تستخدم برنامج حواري.
محتاج كاميرا؟
افضل على اساس ما ادري شلون يسوونها. لازم
افتح كاميرا ولا من؟
عشان افهم بعد يطمن لما يحاول الدكتور يشوف الدكتور معاه.
دلوقتي تفضل.
هلو
مستر رجيب.
الو مستر رجيب. هلو الو هذا عبد الله فلسطين.
رجيف معنا اول ما بيدخل خلاص.
شلون؟
رجيف موجود.
رجيف هو رجيف معنا. هلو Hi, how are you? With you is Dr. Yusuf. We're having some difficulties. We're running late, and that's why we kept you waiting. So we do really apologize. Do you have your presentation on, or you've sent it? Yeah, you can share the screen.
الحين كلهم موجودين معاك بس تقدر تنادي على رجيف يكون معاك اونلاين.
هو كان وياي الحين.
اي كلهم موجودين.
Okay, وياي أنا عبد الله. I will. You can put your presentation. لو سمحتوا صوت شوية صوت شوية.
Can you see the screen okay?
Yes. We can see the screen. Yes. Yes, we can screen. Yes. Well, let me introduce you first. I do apologize for running late, but I do welcome you in our conference, and I welcome your presentation. Dr. Angus, if I can pronounce it right, Maxwell. He's the founder and CEO of Maxwell Geosystems. Dr. Angus Maxwell is an engineering geologist with over 25 years experience in major underground excavation and construction, projects in Europe and Asia. He is founding director and CEO of Maxwell Geosystems, with offices in Hong Kong, Singapore, and India. He has applied his extensive knowledge of geotechnical engineering and project management to develop a company at the cutting edge of data acquisition, integration, and analysis, resulting in a revolutionary approach to project management and the interpretation of data under his visionary leadership and collaboration with a team specialist. Maxwell Geosystems has become a leader in applied system technology, offering innovative and integrated solutions to clients, contractors, and consultants in the construction industry. I do welcome you, Doctor, and the microphone is yours.
Thank you very much. So it's a shame that we can't be there with you in person. Hopefully you can hear me.
I can hear you, but let's see if the audience can hear you. Just a second. How?
Can you hear me okay?
Yeah, he will fix it. Our IT guy here.
Okay.
He will adjust.
Gonna speak now.
Okay, can you speak?
Yes.
Okay, still.
Is that a bit louder? Can you hear me?
I hear you, but I mean, where is the mic here? Huh? Can you speak?
Okay. Is that louder? Can you hear me? Testing. 1, 2.
Yes.
1, 2, testing,
Yes,
everyone?
yes.
Can you hear me?
Now
Okay.
we can hear you.
A lot louder, that's good.
Go ahead.
Okay, well, thank you very much for inviting us to give this presentation. It's a shame we couldn't be with you in person, but I'm sure if anybody who sees this presentation would like to meet either myself or Rajiv, please do reach out. As we say, we are a data company. We have been in construction for about the last 20 years, and we have been operating in a number of different locations around the region. And what we're going to talk about is the use of the digital technologies and innovations we developed really for smart infrastructure, principally during the construction stage. And the example we're going to talk about is the DTSS2 in Singapore. And it's interesting that there is a DSST now being done in Dubai. Now, what we're going to go through in the talk is we're going to go through the, just go to the next slide, just to introduce the project, talk about what the problem was that we solved, then we'll describe a little about the solutions that were proposed and then how we implemented those solutions for the customer, and a little bit about the outcome and the key takeaways of how these things can be implemented. So the project, I'm sure some of you will recognize Singapore. It's an island, and the island has a need for managing sewage and stormwater. And like a lot of countries, it's doing this by putting in a deep inverted siphon sewage tunnel network. And they had two phases of this. The phase one was done in the 1990s up in the north of the island, which is up here, this one here, down to the airport at Changi. And the second phase was this one here, which is down the south, down to a treatment plant in the west of Singapore at Tuas. Now these are large constructions. We're talking 50 kilometers of large diameter tunneling, and we're talking about another 50 kilometers smaller diameter pipe jacks. Now if we just look at the summary of the job, as you can see, 50 kilometers of tunnel, over 50 shafts. We've got odor control facilities, air jumpers, drop shaft, aeration valve, manhole, 450 manholes to go in and link sewers. So very complex project. And the depth of the tunnel was between 35 and 55 meters down. Very similar on a lot of projects. And the problem with this was that we have got more than 30 construction contracts going on at the same time. We've got 50 different organizations having various roles on this, and all of them having to deal with data on the project. There are complex contractual and reporting relationships between people, and the whole thing was made very complex by the arrival of COVID in 2020. So the challenge that we faced was, or the project faced was, how do we manage data? How do we manage the communication of this? We know that if we can get data done well, it can speed up a project, it can reduce risk, but how do we manage to standardize formats, make sure that data is communicated quickly and accessible to everybody who needs it, make sure it's consistent quality, make sure it's transparent so that all the contracts can be managed effectively, and how do we make sure that it's delivered in a timely manner? Quality data quickly. And our experience of the last 20 years is if you do this well, jobs go quickly and they can get completed in good time. So we've got lots of different types of data, and often these types of data from all these different locations, from the treatment plants to the geotechnical instrumentation data to the borehole information to the machines to the cameras to the survey to the production data, they're all done by separate teams. And we have a concept of siloing, which means that people, they protect their own data, they don't share it. So we need to avoid these sort of silos. So the solution was a system called STEMS. And STEM was set up by the government and was an implementation of our systems to manage all the data in one place. And I won't go through all of these, but essentially it managed all of the information about time and records on the project. It managed data coming from all of the machines. It managed all of the cameras. It managed all of the production data. and it managed all of the boreholes. So everybody had one place to go to get to the information that they needed. And you can see that it operated as a central resource with all of this data coming in, and was a place where everybody could go to get to the data they needed on a project. Now, nowadays, this is available off the shelf. You can actually implement these things in a matter of weeks or months onto a project. In the past, it was the risk was, would it be delivered on time? You know, there's a lot of IT involved, whatever, but this has actually been done, so it can just be implemented onto projects. And the great thing is that the data is delivered within context. So as you can see, we have a GIS, so you can see all the information. You can get access to these pins and see the information about reports that may have been published, information about the safety officer, or anything you need to know about a project is there and available in the GIS. And there is rapid understanding of the data, and this is through summaries, so it's summarized for people so they can understand immediately where the projects are. You can see visually how jobs are doing, where they actually are from lining and excavation. We can go through and look at statistics for projects in terms of progress and production. And even when there are many, many, many different parts of the job, we can summarize them so you can see these are pipe jacks, all of the pipe jacks going on the job. So it's very, very common in cities to have this kind of activity going on, and the ease to which you can get to data really is very, very important. And then if you can show it in context, so people can understand this is what it looks like, it aids understanding. And we produce digital twins, so you can see the deflections, you can see movements, you can see monitoring, and you can see the geology of the job at any time. And what we want is people to be able to see the ground risk. So for instance, there are boreholes. I want to be able to get to the information, to see what's there. I want to know every single time, where am I tunneling right now? What is the formation I'm in? And be able to understand information about that. And then we want the information about the monitoring, so I can see at any time what's going on, what's the ground movements, how does it relate to construction, and how the reports are automated. Just automating reports saves a huge amount of time, and you have people who are looking at data rather than focusing just on producing the paper. And we can contour settlements of ground, or we can contour groundwater. We can, as I say, show it in cross-sections. You can see where the progress is. We can show it in longitudinal sections or cross-sections like this. And we can also have predictions of settlements. So this is the prediction for tunnelling, and you can see what the actual settlements were versus the predictions as the TBMs went past. And then when things happen on jobs, when an alarm goes off or something, we need a way to be able to manage that. So we have event management, so people can actually get messages on their phones, and they can actually manage the event through their phones. And they can produce automated reports showing how those events have been closed out. And from the point of view of the insurers, this kind of active management of risk is really, really very important. In terms of production, you've got detailed production going on. A lot of this data is taken directly from the machines. And then we can produce reports like this, where we're looking at the time of various things from plan delay, production, unplanned delay, and codified, so you can get lots of detailed data. You can create dashboards, so you can understand the data that's being provided by the machines. And this is all customizable by the users. And we've got real-time databases, so people can see how the machines are actually being excavated at any time. So these are updated every 3 seconds. We can do that also not just for the big TBMs, but also for the pipe jacks. They're also data logged, and that data comes into platforms like this. And recently we've got vertical shaft sinking machines, which are actually mechanically excavating shafts, and are also data logged. So you've got a huge amount of data that's available that can be summarized and used to project manage the works. We also connect 200 or 300 CCTVs to the project, and this is now available for use of AI, so we can look at trespass detection, we can use them for safety, and having this all in one place is an easy location where the works can be reviewed. And from this we can also connect biometrics. Who is on site? Where? Okay, so we can have that included onto the job. We can also pull in information on reports and photographs and records and have that all in the same library. So you've got one place where everybody can go to get their information. So what did STEMS achieve? Well, you can see in all of these meetings that take place on the job, the system is always up. So every meeting that everybody has, they have a resource they can go to and agree the facts. So as we always say, agree the facts, argue the interpretation. When you're arguing the facts, your job is not going to go smoothly. So the facts, it's transparency, the facts are agreed, and you can discuss them, and it's real collaboration happening. And a lot of things are done very, very quickly. There's a massive amount of savings on hard copies of reports, of preparation of reports. There's lots of opportunity to do engineering that you didn't have the opportunity to do because you couldn't get to the data. Now you can do that. So if you look at across the world now, a lot of people are realizing that data is the key to being able to reduce the risk of poor productivity and safety on construction jobs, particularly anything involving the ground. So the key implementation factors for this were, number one, training and engagement. On this project, we were commissioned with a team to work with all these people. There's 50 companies to try to engage and get them working together. So there's a lot of training involved. There needs to be a 24/7 system support with a hotline so people can go somewhere and ask somebody, how do I do this, how do I do that? And we'll have that continuous support from people. Then you need to listen to people. This doesn't do quite what I want to do, how do I do this? So we need to embrace user feedback, which we did do. And we need to invest in continuous improvement so that people actually get what they want and can do what they want. And then obviously there's organisation, needs to be coordinated. So that our client had an engineer who was the coordinator, and they made sure that the systems were doing exactly what the project was. And key to make this happen is that the management, that's the owner in this case, they were absolutely committed to this being a success and put all their effort and all their full force behind pushing it through and making sure that everybody used it. And the great thing was that because COVID happened, nobody could go to the office. And this system, this STEM system, became the virtual office for over 1,000 people. And ultimately, the main tunnelling contracts of this DTSS2 were delivered pretty much on time, on schedule, and on budget. Okay, so summary and conclusion is tunnelling has got challenges, absolutely. And one way of minimising the effects of these challenges or minimising the risk of them is to make sure that people have the data, have good data, they have it quickly, and they have it in the way that they want. And then if you've got that, you can really make the best use of the engineers that you have on your project. So I hope you've enjoyed our presentation. Thank you very much for your time, and thank you very much to Mr. Abdullah and the rest of the committee for inviting us. So if you've got any questions, please don't hesitate to ask myself or Mr. Rajiv. Thank you.
Well, thank you, Dr. Angus Maxwell, for very informative presentation. I learned a lot. We know that the data is very important, training is very important, monitoring is very important, and all that you talked about, and it's very interesting because working, I don't know, you've talked about the tunneling, but I mean, this is also can be transferred into all different types of plants or pipelines. So it has so many applications, future applications. So I leave the floor for the audience if anyone has a question. Well, there is no questions. Seems, Doctor, I'm very honored to have listened to you, and I do apologize for running late. I hope you understand. Well, thank you. I really enjoyed it, and your system is the way I've seen it. It's very, very important, and it's the future. To put it in different words. Thank you very much. Thank you. Bye bye. Thank you. How to لو سمحت. Okay. Rajiv. How to لو سمحت. وين راح هذا؟ شلون نختار الثاني؟ عبد الله. خلصنا عبد الله. وين انادي عليه؟ عبد الله. اهلا السلام عليكم. الو السلام عليكم. عبد الله ايوه وياي. عبد الله في انت حطيت البرزنتيشن. اوكي. اي رقم كانت؟ لأن أي رقم كانت؟ عبد الله عبد الله الزنام 19.
مرحبا، تسمعونني؟
أسمعك عبد الله، أسمعك، بس أنا بغيت لحظة شوية أخوي عبد الله. وياي عبد الله 19. أوكي. البايو 19 تحرير. هذه أي رقم كانت هذه؟ 19.
19. عبد الله فلسطين.
عبد الله فلسطين 19. عبد الله فلسطين. هذه معكوسة. عبد الله. اوكي. هذا برزنتيشن. شوف عزام عبد الله. ما انا بغيت البايو اعرف. ما يخالف. كيف حالك؟ طيب ان شاء الله. الحمد لله. معك دكتور يوسف الوزان. محاضرتك على الالكتريسيتي اند رينيوبل انرجي كويت. If you can introduce yourself. I don't have your bio now, so if you can just briefly introduce yourself to our audience.
I sent it yesterday. I am Abdullah Azam. I am an electrical power engineer and I work for the Palestinian Central Bureau of Statistics. I act as the head of the statistical section division for energy. I am responsible for producing the energy balance for Palestine, the SDGs for energy, and all statistical energy reports published by our institution.
Yeah, thank you. And you may start, Khoy Abdullah.
I wish that I could be with you and in Kuwait indeed. The last one that I was in Kuwait was in 1990 when I was in the 9th grade. And once I
it's very long time, Mhandis Abdullah. A very long time. Go ahead.
So once I heard the announcement announcement about this meeting in Kuwait, I told myself, why don't I talk about, I usually talk about Palestine and the data of Palestine. But this time I told myself, why don't I talk about Kuwait, the country that I consider my second country. So in the past 2 months, I studied and went through many sources concerning energy and renewable energy in Kuwait. And I came up with the following. As an introduction, Kuwait relies mostly on oil derivatives for energy. Renewable energy production in Kuwait is very limited compared to the total available energy. And there are ambitious plans to advance renewable energy, especially power generation from solar cells and wind energy. Well, approximately 110 megawatts were installed in Kuwait for renewable energy. The available electricity generation now are around 22,500 megawatts for 2024. The projected capacity for 2030 is 32,000 megawatts. And the vision of Kuwait 2035 is to achieve 15% of its electricity production from renewable sources by 2030. If we look at this diagram, it's a diagram taken from Enviro site. It tells that, and for the first time, 40%, 40% of the electricity produced from clean fuels in 2004. And there was a huge increase in utilizing wind energy, that the growth was in 2024 was around 8% for wind energy. And for solar, imagine the growth reached around 29%. This is globally, so we can see that there is a huge growth in renewables, mainly in solar and wind. Now, what about Kuwait? As the data that I reviewed, we have from 2015, we have 7 megawatts installed and increasing up to 114 megawatts in 2024. If we compare the capacity of the renewables compared to the total capacity available in Kuwait, the share of renewables is very, very small. It's around 0.4% of the total available capacity. And if we compare it, as you might expect, from the production side, the percentage will go lower and lower. It's only around 0.2% of the total production of electricity came from renewables. If we look at the SDG 7B1, which says the installed renewable energy generated capacity in developed and developing countries in watts per capita. For Kuwait, it's around 23.6 watts per capita. Now, if we compare this value for Kuwait, for this indicator, with the neighbor countries in the Gulf region and with the worldwide areas, we can see that in Kuwait, as I said, it's around 24 watts per capita, while, for example, in Bahrain, we have 38, and in Saudi Arabia, around 90. In, for example, United Arab Emirates, around 567. In Europe, it's around 1,307. So if we look at this bar chart, we can see that Kuwait needs a huge work in this area. And if we look at the target of Kuwait to reach 15% of the production by 2030, we can see that in 2025, the production, as I said previously, it's very low. And according to the projections, the production will be in 2030 around 27,000 gigawatts hours, and the production should be around 17,000 gigawatt hours. Today we have only 200 gigawatt hours from renewables. So a huge work is needed and expected from Kuwait. To do this, to do the targets, to perform the targets of the view of Kuwait 230, we need just to hit the first stair. Once we hit the first stair, through my real experience, you're gonna do it, you're gonna achieve it. As you can see in this photo, this is our main premises of the PCBS in Ramallah. We have had an idea to construct a PV system on our building, and we started installing this system in 2019 during the Corona pandemic, and in 2021 we launched the project, and we are enjoying renewable energy since 4 years in our institution. So I kindly ask you to try after this meeting to install such projects at your homes, at your work, ministries, etc. Now, I want to compare the electricity prices in Kuwait and the neighboring countries and worldwide. I noticed that, for example, the kilowatt hour costs around 2 or 3 cents in Kuwait and Oman, for example. Then we go higher for Qatar and Bahrain, reaches 5 cents. Saudi Arabia, we reach around again 5 cents, while in UAE, it's around 8 cents per kilowatt hour, while the average worldwide is around 17 cents per kilowatt hour. This means that the electricity prices in Kuwait are very cheap. And as you might know, such prices have many negatives. It has poor targeting. Often subsidies benefit wealthier households more than the poor. And we have increased consumption and emissions. Cheap or free energy encourages overuse, heating and cooling. And the negatives also for such low prices, reduced efficiency incentives, lack of cost pressure, discourages investments in energy-saving technology and renewables, and for sure we have also wasteful practices. Consumers have this reason to conserve energy. For example, they keep the lights on, they use more heating and cooling. My recommendations, well, you could add and give many recommendations in this sector. I will focus on restructure electricity tariffs to better reflect costs and encourage efficiency, enhance data infrastructure for better environmental research and informed decision making, and implement programs to reduce consumption in residential, commercial, and industrial sectors. I took my data from many sources, mainly from the Ministry of Electricity and Water 2024, and from Kuwait Institute for Scientific Research, and many international sites such as the IRENA and Enviro. This is all my presentation. Thank you very much.
Thank you, Engineer Abdullah, for very informative presentation. I will leave the floor for the audience if they have any questions.
All clear.
No, there is one. No, you have a question. Yes.
Mohandas Abdullah, thank you very much for this very informative presentation. Can you hear me? شكله ما يسمعني.
تعال هنا. تعال الميكروفون.
Can you hear me now? Okay, thank you very much for this very interesting and informative presentation. I have two questions. The first one related to your project of installing the solar panels on your buildings. Is that a standalone system or it's with the storage? So is it only just providing the power while there are the sunlight, so during the day, or you have a storage and you are completely off a grid?
No, it's connected to the grid directly. We have no storage.
Okay, so you are using power sharing rectifiers. You are sharing the power between the grid and the solar. So that is reducing your, okay. And that is allowed in your country because, for example, in our countries that is not allowed, the power sharing, because the system have to be completely working when there is power on the grid. So when we lose the grid power, we cannot use the solar, although that you have all your installation. But anyway, that is part of legislations which they are differ from country to country. And in your country, your installation, what is the break even for your installation?
Around 5 years.
5 years. That is a very good figure. And my last question is related to, because you are working with the whole country installations, the more you put solar systems on the grid, especially at the large size, that will have an impact on the stability of the system. And that is now what most countries are facing and trying to implement fault detection and dynamic energy management systems, advanced one, to overcome that difficulty, because you will have a distributed generation different with different level of fault detection than what we have now when we have all our power generation from large stations. And thank you.
Thank you, Engineer Abdullah. يعطيك العافية. I think we enjoyed your presentation. مثل ما أنت لك ذكرياتك في الكويت. من أي سنة قلت؟
أنا كنت من 87 ل 90 3 سنوات درست السابع والثامن والتاسع وللأسف صارت الأحداث.
يا هلا فيك، يا هلا فيكم، يا مرحبا فيكم في مكانكم حبيبي. يعطيك الصحة والعافية، وإن شاء الله نتقابل في other conferences إن شاء الله. حبيبي مشكور، يعطيك العافية، مع السلامة. خلاص ها؟ اوكي خلاص اوكي ايه خلاص. يعطيكم العافية. أنا جيت كذي بالعرض يعني ما كنت مستعد حق بعدين النظر، العتب على النظر في بعض الكلمات، لأن الفونت اللي حاطينه يلا يا دوب، ونظارتي باي فوكل فبقرا شو اسمه، بشوف الحرف على اساس اقرا عدل. بس تساهل، يعطيكم العافيه وحياكم الله، وختامها مسك ان شاء الله. ويا هلا باهل البحرين، يعني حبايبنا ويانا كان صديقنا وعزيزنا دكتور وليد، سابنا الصبح ورجع البحرين. يا دكتور وليد، بعد لا زالت مغامرات المباركية ما خلصت. اتصلوا فيني ولازم اروح ولازم. الله تساهل من رب العالمين ويعطيكم الصحة والعافية. حياكم الله في ديرتكم إيباتي أحد بعد.